for example, if I gave you 3x, the coefficient would be 3. Now, if it was longer like that, I have two different variables, right? That means I have two different coefficients, 3 and 2. So you would just list all of them. Now, if that 2 is not positive, and in fact it was negative, that means this would not be positive, this is negative. So the sign is going to go with a constant. A constant is a number that doesn't have a variable. So if I use the same example, 3x squared minus 2x plus 9, only one of those is a constant. Which one is it? Oh, do you have notes? You don't have notes, right? Yell at me. Anybody else need notes? Which of those is a constant? The 9. Good. And what would happen if it looks like this? The constant would be 0. Because technically, is there a plus 0 out there? Yeah, you just write it because you don't have to. If you put none, I don't think that I would mark that wrong. I'd be okay with that. But I like this better. All right, a term. I don't know why, but a term is very hard for me to define. So let me give you the example first. I don't know why I struggle with this. This right here is a term. This right here is a term. And this right here is a term. And then I'm going to connect those terms with add or subtract. So, what's a term? I wrote something stupid up last period and I don't even know what it is. What? It's the same. It's a group of variables and numbers that are connected with add and subtract. I literally don't know what to tell you other than that. But is it okay, like, looking at the picture and my colors, does it make sense what the term is? So is the 3 the term? No, it's the 3x squared. It's the whole thing. Is it the 2 the term? No, it's 2x. It's the whole thing. Does that make sense? Sorry. Google. We'll figure it out. Okay. I don't know why when I'm talking to like recording, I always have to look at the computer. The degree is the power or the exponent. Now, it is possible if I gave you something like this, the degree of the polynomial is the highest exponent. It doesn't necessarily have to come first. So in this case, the degree would be the 11th. And a polynomial is it's really embarrassing when I record this and I have like no idea how to say it right. A bunch of terms adding and subtracting together. Please forgive my lack of technical definition. But a polynomial in this case, if I just said 3y minus 9, that's a polynomial. Or 7x cubed plus 2x squared minus 6, that's a polynomial. It's the whole thing, yeah. Or you even could have like negative r. That would be considered a polynomial. It's just one, but it's a polynomial. It's an expression. That's what I'm going to write next. It's an expression using coefficients, constants, variables. And I'll add it together. Yeah, it's a little embarrassing. Moving on. Ready? Okay. So we can name these polynomials based on how many terms they have and based on what their degree is. Now, if it has one term, like this one, that's what a one-term polynomial would look like. A two-term polynomial would be something like 5 minus 19y to the 4. I don't know. But it has two terms. Now they could be flipped, they could flip, like, but there's two pieces of it. There's only one subtraction, one term, two terms, minus and 2. If you want to. A three-term polynomial would look something like negative x to the 4th minus 2x squared minus 1. I don't know. So there's three terms. This is my first term, second term, third term. And there could be 5 bazillion terms. I mean, that would be a 4-term polynomial. I'm not very good at pulling numbers out of my head. I usually use 3s a lot, so I tried really hard not to. And then I use the rest of it. No, it could be anything. Now, a one-term polynomial is called a monomial. Because in our language, mono means one. So one term is called a monomial. Two terms is called a binomial. That prefix means 2. 3 would be trinomial. And there are probably words to define 4, 5, 6, 7. But beyond 3, you're just going to call it a polynomial with 4 terms. Polynomial with 5 terms, polynomial with 6 terms. You're not going to memorize the special names. You only need to know those 3. Monomial, binomial, and trinomial. And this comes from the number of terms. You can also classify it by the degree. The 3 that we care about, there are more than 3, but the 3 we really care about are linear. Linear is when you have, so like b plus 7. Like a first degree would be linear. Or x minus 9. When the degree is 1, it's linear. When the degree is 2, it doesn't matter how many terms there are. When the degree is 2, it's called a quadratic. When the degree is 3, it's called a cubic. Doesn't matter how many terms there are. If the degree is 3, it's a cubic. These right here, you need to memorize. Hopefully, after doing them several times, you won't actually need to memorize them because you'll just have them down. Next year, you'll learn what a 4th degree is, and you'll learn what a 5th degree is. That's a 4th. Yeah, but it's called a quartic and a quintic and like those words you don't need to know now. Yes, I mean, yes, it's 1 degree is 4, 1 degree is 5, but you'll learn their special names. So, for this, now your homework looks slightly different. That's my fault. So your homework looks a little bit different. Give me 1 second and I'll kind of talk about what this looks like for you. Right here it asks you by type, I think. And then underneath degree it says number of terms. I've combined both of those into like one question on my notes, so I'm sorry if that's confusing. If I'm looking, we're going to do part A and part B at the same time. If I'm looking at this, the type means classify it by the number of terms. So this one has how many terms? 2. So a 2-term something is called a what? A binomial. So the type would be a binomial. This one has how many terms? 3. So it's called a trinomial. On your homework, this is 2 different questions. Is that okay? The type, trinomial, number of terms, 3. The degree of this one on part A is 1. So that is called a what? Say it again. Linear. The degree of part B is a 2. It is called quadratic. On part A, the coefficient is what? -10. Is the 1 considered a coefficient? No, the 1 is considered a constant because it does not have a variable. But on part B, there are 2 coefficients. What are they? -2 and -3. The 7 is not a coefficient, it would be a constant. So having done that, will you try part C? Now in this one, there's not a number in front of the R. So what is the coefficient of this R? What is the coefficient? -1. Part C, how many terms are there? So the 1, so what would the type be? Monomial. The degree is 3, so it's the cubic. You don't have to put the 3. The coefficient is -1. The constant, 0. And this one, number of terms, is 4, so what would I call that? Polynomial with 4 terms. The degree is 6. Is there a special name for degree 6? Not that you have, so we're just going to call it degree 6. The coefficient is what? And right, from that last one. So this coefficient is a 1, but there's nothing out here with no variable, so there is no constant. I think that's everything that's new. Everything else after this should be a review. So yes. Yes. Ooh, good question. It's always the biggest. Always the biggest. Anybody else? Okay, hopefully this comes back quickly. The first one is we are going to remember how to use the distributive property. Y'all remember how I taught my 7th graders the distributive property? Okay. So when I distribute, we have to make sure every term gets that 9. On each of these, I try to give you a little hint of like, remember how to do this. So 9 times 1, 9 minus 9 times 8, 72x. Can you combine those two further? No. One has a variable, one does not. Next one. Negative 9 times 9, negative 81, and negative 9 times 8 would be what about part C though? How is part C different? Do I combine the 4 and the 6 first, or do I distribute the 6 first? You think about the order of operation. This operation right here would be a subtract. This operation is a multiply. Which happens first, subtract or multiply? Yeah, so we're going to distribute first. Ignore that 4 for a minute. Negative 6 times a 9 would be a negative 54a. Negative 6 times a negative 4 would be a positive what? 24. Once you distribute, then you can bring the 4 back in it. Parentheses, yeah, parentheses are happening. Now when I'm combining like terms, I'm going to combine the 4 and the 24. I like to write them down so the variables come first. I'm going to call it negative 54a, and then what? Plus 28. Try to keep it in, it's called standard form. Like this would not be considered standard form. That would be considered standard form because the variable came first. I guess unless it tells you to, it doesn't really matter, especially on these. Okay, knowing that, try part B. You haven't done so already. Yeah, is there a whole bunch right there? So it's just like 7 times 8 plus 8. 7 times 8. If we write it in standard form, what's coming first? 56k. That's gone plus what? 57. Okay. What about part E? How many times do we distribute on part E? 5. So I'm going to distribute the 5 first. 5 times 3 is 15. Minus what? 5 times 7 is 35x. Now on this one, I have to distribute that negative. It doesn't just like fall off. So negative times 1 is a negative 1. Negative times a negative 6 would be a positive 6. Then we will combine the x's and we will combine the numbers and then we'll be done. So negative 35 plus 6 becomes those two are gone. Make sure whatever sign or number, symbol, whatever, in front of your number stays with it. All right, 15 and the minus 1. All right, next page. Sorry, this is probably not the most fun day. Just got to power through. Next time, I enjoy. Today, no. Okay, for this next part, we're going to do the opposite of what we just did. So on the previous page, we took something that was grouped like this, like this, and we distributed, right? Now I'm going to take something like this and kind of go in the reverse order. So here's how you do it. A factor is a number that divides evenly into another number. To prepare us for what's coming in the future, it is important to know how to factor the greatest common factor out of a polynomial expression. So here's the step. 1, we're going to find the biggest number that goes into every term. This is called the GCF, the greatest common factor. If the leading term is negative, this is part of your GCF. So I'm going to skip down to part B. I think it's a little bit easier. Looking at the 36 and the 27, what number goes into both of those? What's the biggest number that goes into both of those? Because yes, 3 does, but there's something bigger. 9. So 9 goes to both of those. That is your greatest common factor. You put that number or variable in front of the parentheses, like this. And then what we're going to do is we're going to take each of these terms and divide it by 9. So 36 divided by 9 is 4. And when we divide polynomials by numbers, you do the numbers first and then you do the variables next. So 27 divided by 9 is 3. And then there's no case to divide, so I can just put a K right there. So we have undone the distributing, right? Yes? It will make tomorrow so much easier. Next time we see each other is the most important day of the entire school year. I love it. It actually is kind of fun. Okay, that's a little very different from you, but I really enjoy it. In secondary 3, they're doing what we're going to learn next time over and over and over and over and over again. So it's kind of critical. Okay, looking back on part 8, what number goes into both of those? We can look at it as a 2, but then it tells us if the leading term is negative, this one is, I'm going to pull out a negative as well. Again, why? Because it makes next time a lot easier. Our whole goal is to make inside of here this first number positive. Now, if we divide that out, negative 2 divided by a negative 2 is a 1, and then we just have that A. A positive 10 divided by a negative 2 is negative 5. Let's do it again. But this time on part C, I have variables to consider. Again, look at the numbers first, look at the variables second. Looking at the numbers on part C, what does 6 and 21 both have? Yes, they have a, yeah, looking just at the numbers though. They both have a 3. Now, each of these terms have at least one x, right? One of them has more than one, but both of them have at least one. Can you agree with that? So because they both have at least one, I'm going to pull that one out. Just watch. So everybody, instead of finishing writing this down, let's just watch for a second and then I'll have you write it down. Because they have it in common. They both have an x in common. Now looking at it, 6 divided by 3 is 2. And then looking at this term still, if I had 2 x's, I take one away, how many x's do I have left? 1. Now if I were to multiply those two, do I get 6x squared? I should, because that's what I broke this up, right? Now going to the 21. 21 divided by 3 is 7. If I have 1x, I divide it out, I'm left with none. So that is my answer. Write it down. Again, the point is to make next time easier. And then the point of that is a whole different like conversation. But the point of this is to make the next time easier. The easiest unit we do? I don't remember. Yeah, I don't know. Okay, next one. Looking at the numbers. First of all, the leading term is what? Negative, so a negative is coming out. Looking at the 6, the 3, the 12, they each have a 3. Looking at the ends. How many ends do they have in common? They all have at least one end, right? So that end comes out. Now we divide. Negative 6 divided by negative 3 is 2. I have one end. I take the 1 out. No more ends, right? So it's just 2. Next one. Negative 3 divided by negative 3 is a positive 1. I have 2 ends. I took 1 out. N. Now, do you technically need the 1 in front of the n? No, but I'm okay that you put it there. Negative 12 divided by negative 3 is a positive 4 n squared. Good. I had 3, took 1 away. Just feel like the 99 bottles of beer, right? Like, take 1 out. Pass around the end. Okay, no. Take 1 out. Part E. Why don't you try it? I think the unit that we factor, I think the unit that we graph quadratic and then graph absolute values. I think that was when we did the highest value. Oh no, that's probably that is looking more like 7. But it's the easiest unit for years because we've already done unit 7. Becomes tricky, and then I don't know what it's called. I don't know. They're all equally hard. You just get something harder, but it's not harder because you've learned something before. I don't know. The ones that I always think are easy, everybody just screws up on, and the ones that I think are really hard, you guys do good. Okay, are we pulling out a negative? A negative what? 4. And then they all have at least. Now, it is okay to pull out more than one x. See, they all at least have 2. So let's pull out all 2 of them. All 2 of them? Doesn't matter. All 2 of them. Yes, you need to. Because if you didn't, it would be x cubed, x squared, and then still an x. So they all would still have something in common. So you didn't pull out quite enough. It's kind of like, does it matter if I only pull out a 2 instead of a 4? You have to pull out as much as you possibly can. Yes. All right, divide. 32 divided by 4. Negative, negative, cancel 8. There were 4 x's. Take 2 out. Good. Negative 20 divided by a negative 5 is a positive 5. Then what? X. Good. Go to the next one. Plus 3. Who got that? Good. It's coming out easier, I think, from us. It's not easier, but better. All right, part F. Try it. What comes out of part F? What happens when the entire thing comes out? This is the first time it's happened, right? What happens when the entire term comes out? Do you agree that 3m squared each of them have? They all have a 3. They all have at least 2m squared. Here's how I would look at this. 3 divided by 3 is 1. You have to have the 1. Yes. It's a placeholder, sort of. We don't want to do a negative because my leading term is not negative. so I'm not going to do a negative. I won't do a negative on part G, but I will on part H because they're leading, yeah. Now, M, took both of them out, so it's just 1. That's okay. Negative 6 divided by 3 is a negative 2. M to the 5th. Very good. Minus, ooh, that hustle. Minus 5m squared. Moving on. Very good. I would skip part H, except for this is the first time we've seen multiple variables. You do it the same way. The number we pull out, they each have a what? But I don't want to pull out a 6, I want to pull out a negative 6. Now look at the C's. They both have at least how many? 2 C's? And they both have 1 D. Good. 36 divided by 6? 6. The C's are gone. How many D's are left? D's of 4. Is that okay? That was fast. Looking at the next term, 42 divided by a negative 6 is a negative 7. How many C's are left? How many D's? None. Done. Nope. Nope, nope. Okay, cool. Now let's talk about adding and subtracting. Again, I'm sorry, there's a lot in one day. We can skip around, I think, a little bit more with this because I think you're more familiar with it. Was this new? Or have you done that before? New? Okay, adding or subtracting. Are there any keys? Okay, we have to look for the operation. This symbol right here matters. Do not confuse this with multiply. Multiply looks very similar. If you flip the page, kind of like to the back side, the top problems on the next side, they look very similar. The only difference is there is no symbol right here. So look at this one. See how there's nothing in between there? That's a multiply. But if there's an operation, all we have to do is add. So we're going to do that operation to combine the terms. So if I'm looking at this one, this is a like term with that. I know they are a like term because they both have the same variable, the same power. That should be review, right? So 2n plus 2n would be 4n. You don't have to do anything with the exponents, just 4n. And then if you have the minus 7 plus 3, it's going to be a minus 4. That's all you got to do. Now, can you combine those and make like a 0 and something weird? No, they're different terms. You can't combine them further. Looking at the next one, I like to do the k's first because they're the leading degree, the highest degree. What would it be? How many k cubes? You're calling it. You got 1k cubed and 6k cubed make 7k cubed. There's a 1 right here. You have a minus 3, a plus 5, plus 2. Can you do anything else? No. Now in the instructions it tells you to be very careful when you subtract. This is why, don't write this down. If I see people make mistakes, they say 8p minus p is 7p. And then negative 7 minus 5 is negative 12. That is not fully correct. It's close, but it's not fully correct. Because what needs to happen, I want to subtract the entire binomial right here. So I want to subtract the p, but I also want to subtract a negative 5. So I'm going to distribute that negative, rewrite it. Negative times p is a negative p. Negative times a negative 5 would be a positive 5. So when I subtract that negative 5, it turns positive. Then I combine like terms like I did on A and B. So 8 minus p, 7p. But then what? Minus 7 plus 5 is minus 2. So like I said, be very careful when we subtract. Try part D then. So we have to get rid of the parentheses. You can't really subtract. That's a good way to look at it. If there are parentheses, distribute that negative. Negative 6 times A, positive 8m squared. Let's combine the m's first. You combine those, what do you get? 5m squared. And then what? Minus 1? Minus 7. Ones that don't have the what? I usually start with the highest variable, actually. That way my highest variable is always first. That's called, oh, look at that. Make sure your solution is in the proper order. Largest exponent first. This is called standard form. So I like it like that. Technically, if they're flipped, it's not wrong. Unless the problem tells you to put it in standard form. So that would be. So on your own, will you please start or try part E? And check out how much you know. Are we going too fast? Or are you okay? I feel like we're going through it faster than my last class. Anything good? You're fine then? When you're done, give the person sitting next to you, make sure you get the same thing. Okay, on this one, distribute that minus 2r plus r squared. Now, the 9r squared combines with which other one? The r squared. They're not listed in the same order this time, but that's okay. 9r squared and 1r squared will combine to 10r squared. And then you have a minus 7 minus 2 will combine to make minus 9r. How did you guys do? If you did it wrong, do you see where your mistake was? So it's okay to do it wrong as long as you can see, oh, I combined the wrong ones or whatever. Well, how come the exponent went before? That's a very hard question to answer. When you multiply, so if it was 9r squared times r squared, that's when I add those exponents. But because the add is kind of like I'm 9 oranges and 9 oranges, well, I got 10 oranges. So I don't do like 10 oranges squared, it's just I got 10 of them. Is that okay? They don't though, because when you distribute the minus, it now becomes a plus. Let's do one more. Just to make sure we're all in the same orange. Yeah. So looking at part G, let's just go right down below it. I'll go a little bit slower. Sometimes I get excited and I just like to zoom through it. We need to start part G by doing what? Distributing. So I like to rewrite it. I feel like I'm less likely to make a mistake. So when I distribute, I'll have a negative 2, a what? positive x squared and a positive 2x. Once I've rewritten that, you can completely disregard the problem. Then you look for your like terms. Again, I like to start with the highest exponent because that's putting it in standard form, and that's how I like my answers, in standard form. So the highest exponent is x squared. After that, what can I combine? The 2x and the negative 3x. Is it negative? Is that okay? We didn't have to change that sign, right? You only change the signs afterwards. So combine those, what do you get? Sorry, what? Minus what? This one right here? This one? Well, when I combine this, because that's a minus, with the positive 2, sort of. It depends. It depends on what your answer is. When you combine them together, if it's negative, I bring it down. If it's positive. So if this was the negative and this was the positive, then that would be the positive. That minus right here makes the 3 negative. This one? Yes. This negative is combined with a 3. Like it is a negative 3. Okay, one last one. Yes. Correct, you cannot combine them. They have to have the same variable, or power. Last one, 4 and the minus 2. So 4, the negative 2, positive. And again, that's positive because when you combine 4 and a negative 2, positive answer plus 2. Okay, moving on. All right, now we're going to multiply polynomials, which we've done a little bit today. Another way you could look at this is like a double distribute. I believe this is review. Some teachers use the word FOIL. You heard the word FOIL before? Maybe you have, maybe you haven't. Okay, I don't use that a whole lot, so there, I don't. I'll tell you what it means in just a minute. Before we do the multiplying, just a quick reminder. If I have A plus A, what would that be? 2A. Kind of like an orange and an orange. I got 2 oranges, right? That analogy makes sense until you get here. If I have A times A, it would be A squared. We learned that last time, right? If you have A squared times A, it would be A cubed. And if you have 2A cubed times 3A squared, it would be 6A to the 5th. We need to know that to be successful down here. Yes.
Why is it like 200A squared times A? I didn't play with that word, but I did the other word you have to add.
We did add that one. Right here. What? 2 is 1 and... Oh, yeah, because without anything there, it kind of looks like a 0. So no, we did add it because there was no one there. Good question. All right. So we're thinking of this as kind of like a double distribute. We have to distribute the 3x to both of those. Not to the 6, because it's in parentheses together. We're going to take that 3x and we're going to multiply it to the 2x. When I multiply those, what do I get? 6x what? Squared. And then 3x times 6 is what? 3x times 6? 18x. After I distribute the 6 or the 3x, now I'm going to go and I'm going to take the 6 and do the exact same thing. So we'll multiply here and get 12x. Now I'm going to strategically place my 12x underneath the 18x because in the end they're going to combine together. They have the same variable. So this is why it's called a double distribute. I distribute the 3x Now I'm going to distribute the 6. I get the 12x, and then I get the plus the 36. In the end, we're going to have terms that are the same, and we can add them together. So, if this doesn't combine with anything, it would be 6x squared plus what? 30x plus 36. You never taught secondary one. Not. Yeah. Okay, part B. Do it again. So we're distributing twice. I'm going to multiply 2 times 5v, and I get what? 10v squared. 2v times a negative 4 would be a what? Negative 8v. So that's my first distribute. Now what am I going to do with the negative 4? Distribute again. Negative 4 times 5 would be negative 20v. Now I'm going to put it underneath the 8v because those are the same terms. Negative 4 times a negative 4 is a positive 16. Then I combine whatever terms I can. The first term and the last term will never combine with anything. So I just have 10v squared minus what? Plus. And a slight side note, something that's really hard with imaginary numbers got taken out of our course, so we don't have to do it. There's something that we'll learn on day 4, and it's called imaginary numbers. And we would have to take like imaginary number raised to like the 44th power, and we would have to tell me the answer with one. Like it's not that hard, but it's confusing. Yeah, and everybody looks at me like I have no clue what you said. It's imaginary. Okay. Sorry. Moving on. Part D. Try it. Part D. Quickly try it. We have 8 minutes left, and I've been talking the whole time. I'm so sorry. b squared times a 7b will give you what? 35b cubed. 5b squared times a negative 6 will be negative 30b squared. Now we're going to distribute the second time. 2 times the 7b is... Now does 14b line up with either of those two? I'm going to put the 14b on the outside. Keep going. And then the 2 times the negative 6 is negative 12. Does anything combine there? So it is possible that there will be no like term, in which case your answer is this. Now, really carefully, I told you that, or really quick, I told you at the beginning that some teachers use the word FOIL. This is why. The F stands for first. We multiply the first ones together. The O stands for outside. But isn't that what we've done, right? We distributed once. The I stands for, any guesses? inside, and the L stands for last. That's what we've been doing, right? So that's why they use the word FOIL. FOIL is a solving method. It's not a mathematical concept. So it shouldn't be like on the stage or anything because it's a technique. But I saw it on the stage last year. So. The word FOIL should not be on the stage really. Really quick, part E though. Let's try and finish this up in the last 2 minutes. Part E, when I distribute this time, how many times do I have to multiply that P through? 3 times. So P times 4P squared would be 4P cubed. P times 8P would be 8P squared. P times 2 would be 2P. Woo-wee. Is that okay? Miserable, maybe? Are you miserable right now? I can totally tell. Like half of you are like, will you please shut up? I'm sorry. Moving on, almost done. That, by the way, is on the recording. Second period does not want me to keep talking right now. 5 times 4P squared is what? 20P squared. 5 times 8P would be 40P. 5 times 2, 10. Combine what you can. 4P cubed plus 28P squared plus 42P plus 10. Are you okay with that? Perhaps miserable. I am sorry. Ooh, except for this is not a cube, it's a square. I know. They have different variables. So different power. It's because of this right here that you can't combine them. Again, very hard to explain. You don't add exponents unless you're multiplying. So if I were multiplying these two, then I'd add them. All right. Nope, we were going to start the phone sheet next time so we can put our phones in. Good job. Thanks for watching. Peace out.